Hi guys, I'm Garrett. I found an article online talking about how C and C++ were a dead language like COBOL, and I found that hard to believe from the headline alone. So I dug in a little bit more, and the more I read it, the less it made sense. My background is in C++, particularly with operating systems and drivers and some embedded stuff too. So that's kind of the look I'll be taking at this article. I hope you guys enjoy. Alright, so recently I found this article over here. It's talking about how C and C++ are a dead language, just like COBOL is. And I found it interesting because I've learned C and C++ in school just as a sophomore over the last year. And COBOL, and I've just started a new project in C++, all this. And if it's a dead language, I don't know if I want to go down that road. So he starts by talking about he basically hates C and C++, and C and C++ are very bad at security, which I agree with. But he also basically bashes every software developer because it's not of concern. It's not a concern and nobody actually cares about it, which I find is a little bit disenfranchising to the average audience, to the audience of this. But then he goes into, right in this paragraph, saying that he's very confident saying that it's dead like COBOL. No new code's being written in COBOL and by extension C and C++, and it's just a maintenance language. And he starts by giving they're too hard to use, which, yes, C and C++ are a hard language. It is easy to segfault. Safe languages don't let you do that. But it's like, a lot of times you need the unsafety of a language, the non-safety of a language to be able to do things, right? Every teacher that I've ever had has told me C and C++ is like a pile of rope. It's long enough to hang you and everybody else if you tie a noose, but you can make these really amazing, really useful pieces of code. And by extension, safe languages would be a pile of rope that you can't tie a noose in. And on the surface, that sounds fine, right? If I can't hurt myself, then where's the harm, right? Nobody likes hurting themselves. But then you look into knots and you find that the knot that you tie a hook onto a fishing line with is the exact same knot that a noose is tied with. So now you can't tie your fishing hook onto your fishing line and you can't fish. So if you can't tie that knot and you can't do certain things, you can't create certain things. So safe languages, although easier, may not be able to create everything. So it's hard to program. He talks about how it's easy to write bugs, and these bugs are often not caught by a compiler because, well, if you make a null pointer and then use the null pointer, sometimes you want to do that. Other times you can't. And he talks about how they're discovered a long time later, and the programmer has moved on, the programmer is dead, programmer is nowhere to be seen. So you can't, so that causes issues. Fine, I'll give you that one. It's hard, it makes bugs. They're voting with their feet against C and C++, just like with COBOL. He says the vast majority of new code is not written in C and C++. They use these safe languages. And that's true to an extent. And I don't think that there's a problem with new code being written in a safe language, if that makes sense. But if I walked up to a new project and I needed to do a whole bunch of work with low-level code and do coding with pointers and deal with the actual hardware on the board itself, I would not choose JavaScript. I would not choose Ruby. I would not choose PHP. I would not choose Python, R, Haskell. I don't even know what language that one is. I wouldn't choose Go. I wouldn't choose Java. I wouldn't choose Swift because they can't do the hardware level manipulation that something low level requires. It almost exclusively requires a low level and unsafe language. C and C++ are the gods in that field. So, there's no way, there's no sign that C and C++ can reverse this. Just the opposite. The frameworks have died out. ActiveX has died out, as it should have. Android used Java. iOS moved to Swift, and instead of the horrible language that Objective-C was, I don't think they chose Swift over Objective-C because Objective-C was an unsafe language and Swift was a safe language. I think it was because Objective-C was just a generally garbage language. The generalization that he makes here is every new program, all new programming, new programming languages, they're all safe languages. He says that it's not because C and C++ are perfect. And I agree. C and C++ can come a long way, and they have come a long way. In 2011, we had the auto keyword introduced. Well, in 2011, we really had a lot of pieces introduced. But, and they're ever growing. And they steal features from these safe languages, like auto, like templates, like all of these things. And I know they have flaws. But the reason they're not creating unsafe languages is, yes, there is little demand for a new one because C and C++ are the de facto king. You would have to create something totally new, something totally different. It's hard to innovate in the space of these languages because, and you would need that innovation to even think about dethroning C and C++. Now here's a bit that I really like. So there's definitive data. He doesn't know whether there's definitive data, but everything that he says backs it up. He uses the TOPY index on language popularity. So I did a little bit of research on this index, and I was expecting this index to take into account new GitHub repos, new lines of code committed, all these like code pieces. But instead, this index uses just the number of hits on the languages, and only with the keyword search language plus programming. So C++ programming, C programming, JavaScript programming. Yes, that is a good way of showing what a semi-popular language might be. But there's not this real clear answer in this if you only look at the search engine results. I feel that should be a part of the index, but not the entire index. So, if we take a closer look at this graph, we look that the de facto, the king and the queen of this is Java and C, followed by C++. Now, over the last 15 years, this chart shows we have a 10%-ish drop. So less than 1% a year C++ is dropping in popularity. C has dropped, if we ignore the last year of a steep decline, C has dropped maybe 5%, if you could even call it that. And over the last year, it has dropped another 5%. And then you have all the other safe languages that aren't Java, squished down all below C++. And I could come up with about 20 different reasons that C++ is declining in popularity. I could see that there's more languages, so more of our market share is taken up by that. I could see that there's not many more articles that people want to write because every article, every tutorial has already been written. Now, I know that's not true, but with the introduction of more languages, the languages that take a lot of these and make a lot of these, you would see a decrease in a rating. Now, I don't see that as a big stat or a stance that really anybody should look at, because again, it doesn't have to do with the actual code being produced. Let's see, the unsafe languages, C++, assembly, combined for more than 35% of the market share in 2002. In 2017, they're less than 20%, which I'm thinking they're right at about 20%, maybe 19%. But if we look at the change, it's 1% a year. If I said you're gonna make 1% more of your income or 1% less of your income a year for the next 15 years, you wouldn't be too scared, right? It's not that much of a change. Long-term trend is consistently downward, which, yes, if you look at the graph, there's a downward line. But I don't think that's because they're dead, right? You don't even see COBOL on this graph. COBOL's a dead language. Now, systems programming. That, what I was just talking about at the beginning. It's a niche that C and C++ dominate. He agrees. But if a safe language, he says that if a safe language, let's try that again. So he says that if there is a safe system library, if it can be built, it will displace C and C++. And it's going to happen. So what he's saying is, if we can figure out a way to do C and C++ in a safe way, then it's going to displace C and C++. But you can't. There have been attempts to do that. But when you have crazy pointer casts, and you have to be able to take and cast or create a pointer to a specific point in memory so that you can write to a hardware device, that's inherently unsafe. So you can't make a safe language and then do inherently unsafe things. It doesn't make sense. So he argues that it's going to happen, which I don't know how it can, but he argues it will. He made an attempt Cyclone in the early 2000s. Obviously, it never went anywhere because I don't think anybody's really heard of that. Rust is another example that he uses. That's a interesting language. I have not dealt much with Rust, but if Rust can do everything C and C++ can do in a safe way that's just as fast, I could see it taking over some of that market share. I could see starting to talk about C and C++ dying. But I don't see that right now. Those languages don't rely on garbage collection. Thank God. Garbage collection is inherently slow. It causes lag spikes. And when you're trying to take and switch between two user programs in an operating system, that's a bad time for the garbage collector to kick in. If you're trying to land a probe on Mars and it's 100 feet from the surface and it's going to take 1 second to get to the surface, that's a bad time for a garbage collector to kick in. So at least we have that. And again, he argues nobody's creating unsafe languages, even for system programming. Sure. I feel personally that these safe languages are a fad, a trend. Everybody likes them because they're easy, and then they're going to try and do something more advanced, and they're not going to be able to, and then they're going to look for an unsafe language to do that. So here's an interesting section. Legacy code will never go away. We like to, I'll say we because I am a fan of C and C++. I'm an advocate. They like to point out that legacy code will never go away. And I think we can all agree with that. There's still Fortran, there's still COBOL out there. But they're not relevant to what they're writing today. I'd argue that they are because something like the software running insurance agencies and banks are still in COBOL and Fortran, and they pay lots of money for these developers. So there's that. They do get rewritten though, and I agree with that sentiment. They love to re-implement the wheel. They love to call the last programmer that worked on a project an idiot and make an argument that the whole thing should be thrown away and replaced. And that's probably true for something like COBOL. But not for C++ programs yet. He argues that, he doesn't argue. C and C++ advocates argue there's too much code in operating system kernels to replace. There is a lot of code. The Linux kernel is several, I'd put it in the order of a million to a few million lines of code. Something like GCC, the compilers, is 20 million lines of code. A minimal C library is 2 million lines of code. That's a lot of code. Could it be rewritten? Yes. Now he argues about mixing safe and unsafe. So, iOS has a kernel written in C. It's based on BSD and a couple other things to form its kernel. It's written in C. There may be some C++. I haven't looked at the exact code. He also says that there's a smaller kernel based on the L4 microkernel. This runs their secure enclave. This stores all the cryptographic stuff and the fingerprint and all the secure stuff into the name secure enclave. It's a special piece of silicon that runs that microkernel. And I agree with this sentiment. Less code is better. The less code that you have to look at, probably the secure it's going to be, because there's less pointers, there's less structural problems. Now, he says that L4 is written in C, and I could agree with that. It's small enough to formally verify. Sure. I feel that it's hard to verify code, but he's the security expert here. I'll believe him. And it's small enough to be rewritten in Rust. Yes. That's all fine and dandy. Right? I wouldn't mind seeing how L4 gets rewritten in Rust. And it looks like in this, he has provided an example of where it is, which is wonderful. Then he says Linux can run in a compatibility mode above that kernel, or any safe hypervisor, preferably, I guess, written in Rust. But that doesn't fix all the security issues. If, like, Dirty Cow was not a kernel problem, it would not have been fixed by L4. It would have been in the Linux source code. So the only way to fix Linux is to run it or to rewrite it. And Linux is a monstrosity. And nobody's going to want to learn Rust to contribute to Linux. They know C and C++. It's taught in almost every college across the country, I'm sure. It's so influential that everybody knows about C++. If you want to get into drivers, you learn C and C++. If you want to do operating systems, if you want to do kernels, if you want to do embedded systems, C and C++, maybe a touch of assembly. Unsafe languages. But, he says, once bare metal software is written in a safe language, C is going to get squeezed from the low and high end. And he talks about how to accelerate this death, how to kill it. We should eliminate buffer overflows. We should just stop using unsafe languages. Now, throughout this, there's a few interesting points. He never showed in an example of where new projects aren't being written in C and C++. They're losing popularity, sure, but not in code, in articles being written. They're not doing all these. He never shows this solid, concrete example. He also doesn't argue that. He always argues that it's going to die. If this happens, then it's going to die. Not, it is dead, right? If we can get a systems language that is safe, then C and C++ are going to die. But until then, it's not going to die. So how is it dead? Now, I also find it strange that how do I want to word this? Has something like Rust, which is this systems program that he wants everything to be rewritten in. Let's say it's 10 times slower than C, which is a reasonable estimate. When you're doing time quantums and you're doing an operating system, 10% of that time has to be less than 10% of the time should be switching contexts, and the rest of the time quantum should be running the actual application that's trying to be run. So if you slow it down by another 10%, you lose the ability to have small quantums. And if we used an extreme example where instead of Rust needing 10% to run the code, it needs 50% to run the code, then all of your programs are going to screech to a halt. It's going to look like you're running Windows Vista on minimum settings from a computer built in 1950. It's not going to work. We have worked so hard to cram so much processing power into these computers. Operating systems are purely overhead. If you add overhead, you're going to slow down the system. Nobody's going to want to use an operating system that runs slower. Everybody's trying to cram the most power out of the hardware they have. So if you're using Rust and it slows it down, you're doing yourself a disservice. I would be all for a safe language that can do everything C and C++ can safely and have the same performance as C and C++. I'd switch immediately. I'd say C and C++ need to die. They wouldn't be dead yet. there would be tons of code in C and C++. I'd be an advocate for rewriting it because you'll have less bugs, less security holes, less buffer overflows, less buffer underflows, all of this stuff. But you won't, because the performance and the ability comes from the inherent unsafety of it. That's just my thoughts on the article. I'd like to hear what you guys think about it. The link for this article will be down in the description below, and leave comments letting me know, am I totally off base? Is C and C++ really a dead language? Should I stop writing C and C++? Should I learn Rust? Should I learn Go? Or am I right here? Or is there some in between that I'm missing? I'd love to hear what you say. This is Garrett, and good night.